Assalamualaikum and a very good day. We meet again on our lecture for the fourth series, and today the main purpose of this lecture is for us to explore the software that we are going to use in the class. Okay, it's a free software, means that everybody should download and install it. And today I'm going to teach you how you guys can use it and what is the best thing or the important things that you need to look at and understand the concept of the microprocessor programming. Okay, so you can download the software from the internet. You just Google it, Google for Easy68K software. And then you can just go to this link and you can get it for free. So this is the one, you can download it for free, then you can install it, and then you can run the applications. So this is a screenshot. Let's see that I've already downloaded it and installed it, so I just can go to my search box over here and then just go for Easy68K. Okay, this is your interface on your software. So it's very simple, right? So you can see that when you start your editor, when you start your software, this is the first page it will come up. Okay, right? How to use it and what are the things that you need to look at over here? That is very important because you need to understand how to run. So first of all, why we need to have this software is because that when you do the programming, okay, when you do the programming, you need to write it on the software, and then you need to compile it, and then finally you can get the machine code, or you can call it the hex file. So the code that you write is the one that you understand. Okay, let me just write down over here first, or maybe just Word. Okay, this is the one. Okay, when you have a programming, when you want to do programming, right? So this is your programming. The first thing that you need to know is how to write. Then the place to write. For example, I'm not so sure for C++, you can relate back to your C++. You write the code and you know what is the software that is going to be used for your C++. I'm not so sure about that. So it's okay. So why you need to have this one is because when you write, for example, in this IDE 68K, Easy68K, you have the editor. You can write down your code in the language of, they call it assembly language. Okay, this is the language that you are going to learn in my class. Okay, it's very low level language, which means that it's not that high level, very easy like C++. But in terms of skills of programming, it should be the same. Then why you need to have this software? After you write down all your codes, you need to do the compilation. Some people say the reason of compilation is to get the error, to find the error or other things, but the main purpose of compilation is basically to compile your assembly language code over here to change it to .hex file. This file is the one that going to be recognized by the machine. The machine cannot understand this code. Okay, the machine cannot understand this one. Machine cannot understand. That's why you need to do the compilation, then the machine can understand this code. Okay, so in this process, right, that's why you can find out that this compiler will detect the error. Of course, if there's error, it cannot compile it to the correct hex file. If there's a syntax error, that is the main thing you can catch over here. For the semantic or the flow error, the compiler may not able to detect it, but majority of the, not majority, all of the syntax error must be detected at this area, at this process. Okay, so this is your program. Okay, this is your program. When you open up, this is the program that you can write. This is your interface for the first program. Normally, when you want to write a new program, my advice is, my recommendation is, you have to have a dedicated directory in your system. So for example, that if I want to have a new code, right, so I'm going to create a new directory or folder in somewhere that in my PC, that test BEKC 3453 IDE tests. Okay, so this is my folder. All right, let's look at this code. I'm going to write down the code later, but now we are going to look at this interface by default. So you can see that there's a blue color over here, and this is green color, purple color. So in coding, normally it will have the color coded version, where you can find that by using this color coded, you can easily find the errors on the syntax. So you can see that for the blue sections over here, okay, this is considered as the command, which is not going to be compiled by the compiler. Why? Is because that in the beginning of the lines, right, you have this asterisk symbol. So if you remove this asterisk, then the color will be different. So you must have this one, because if you want to put a notes or something that you want to put the names or whatever comments in the beginnings of the lines, you must have this asterisk symbol. Same goes if the comment is after the syntax, you must have this semicolon. If you remove this one, this is wrong already, means the system will try to compile this command, this line. So you have to put as a semicolon here, means that when you compile, the compiler will not going to take care about this one. It will going to ignore it, and then it will compile whatever command that is not being as a comment over here. Okay, so let's try to just write a very simple code. Okay, I just want to remove everything here. Okay, just remove here and this one. So this is very basic program where you have the first syntax lines and you have the end. Your program must be written between this head and tail. Okay, between this one. This is the body over here. Okay, let's just write one command, very simple command. It's just maybe move .byte hash AA to D0. Okay, you can save this file. Okay, first thing, you can go back to your directory just now. Inside this directory, there's nothing yet, so you can compile it. Sorry, you can save it first, then you can go to the particular directories, and then there's nothing here, right? So the first file will be saved as the .x68 file, which is going to be the test. I'm going to put a name over here, test class fundamental basics. Okay, save. And you can go back to your directory. You can have the basic one as this file as Easy68 as a source file. So this is your source file. Okay, source file is the file that you can do the editing. Alright, once you complete, let's say for example you have completed all the writing code, right, then you want to compile it, you just go to this play button and then you just click hit assemble source, or you just click or just hit F9, but you can do this one. Then there's an error. Okay, undefined symbol. Okay, right, so there's a problem here. See, when I have a problem, then I'm going to have a error pop up over here, so I have to fix it. So I just do this one. This one should be going to be this one, hash $AA to D0. Let's try to compile again. So there will be only one warnings, and then there's zero errors. It's error free, and then you already compile it. Just close this one, and you go back to your directory just now. Now you have two more files being created after you do the compilation, which are the srecord file and then the listing file. Okay, this one is the one that they call it like the hex file here. You can open up this one, just open up with a notepad. You cannot understand this. This is the file which is going to be read by the CPU, and then this is the one that is going to be understand, not us. But this is the same thing what you write down on the assembly source just now. Okay, you write down on the interface just now. Okay, what else? List file. You can open up again by using this one. Okay. Let's open up this one. So the listing file is like this. This is more like a complete notes. You can see that this is your command just now, and then this is the location where the command being reserved in the memory. Okay, so the listing is sort of complete, where you want to see the codes, everything. This is a details out from your code just now. Okay, let's go back here. This is your compilation. So this is your code, then you compile it, right? Then what you want to see, you can just go to your project. Oh no, sorry, you just go to the you just go again this one, run, and then execute this one. So this is to execute, means you want to look at the execution. Then will come up this one. So in the last lecture, you learned about the software modeling. Remember that the software modeling is referring to the registers inside the CPU. Then these registers you cannot see by your eyes, direct eyes, your naked eyes. It can be seen by using a software, which is this software. Okay, you can look at it from this one just now, right? So you have the location, the group for D. This is a registers for grouping D. For A, address, SR, the parent counter, US, and SS. So this is the one just now, like your listing file. Can we open up the listing file again? So listing file. View. Sorry. Is it the same? Yeah, it's the same. So listing file will be here. More, it should be a detailed one, because you can see that what is actually happening on the system right now. So again, okay, look back of your software modeling. Remember that the registers only can be seen by using the software. So I'm going to open up back the old lectures notes. Okay, so I put it for this one. And then look at this one. So the registers inside the CPU, we have the data registers and the address register. This is data register and this is address register, right? So the first grouping is D0 to D7, and the second grouping is A0 to A7. Okay, whereas A7 is related to the stack pointer, which is this is a stack pointer basically. This is alright. This is stack pointer. So the registers that we are always looking when we want to do execution in this class is this one. The first one is this one. The second one is this one. And the third one, okay, I'm going to use this one. This is SR, it's a status register. Okay, this is the third one. And the fourth one will be PC, program counter. So the program counter is referring to this one. Okay. The address is referring to this one. The data registers is referring to the data registers inside the CPU. Okay. And the status register here, the blue color, will be referring to the status register over here. So these are the registers you can see by using the software. And remember that I always keep on emphasizing that this is the pins for data pins, and this is the pins for address pin. These are not the same like inside here. Again, the software modeling can be seen by using your software. Okay, look at the sizes. So right now the size is 32-bit for data register. So this is 32-bit. You look at this data register. So is it 32 bits over here? How many digits over here? 1, 2, 3, 4, 5, 6, 7, 8. 8. This is 32, but this is 8. Something is wrong. Same goes to address register. The size is also 32. And then you can go back to the address register. You count back 1, 2, 3, 4, 5, 6, 7, 8. 8 only, not 32. Then you go to your program counter. Program counter got 32 also. You count back 1, 2, 3, 4, 5, 6, 7, 8. 8 only. And then you have the status register, 16-bit. Then you count back this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is correct. So this is correct, 16-bit. But why the rest is different? To answer that, the other registers on Easy68K is represented by hexa numbers. Okay, I'm going to repeat this. So all of these registers is represented by hex numbers. So the hex numbers is a number which is base 16. Now you can remember that if you can go back to your revision sections on the digital, each of the hexa number, if you convert it to binary numbers, is going to be 4 digits. For example, again, I like to put number 10 in decimal. 10 in decimal is equivalent to A in 16. Okay, A in 16, right? So then you have the binary. When you want to convert this one to binary, this one should be 10, and then the binary number will be going to be 1010. Okay, so each of the hexa numbers will give 4 digits of binary. So is it going to be the same one? So now you have how many digits? 1, 2, 3, 4, 5, 6, 7, 8. So each of the digit over here will give you 4 digits of binary. So 8 times 4 is equivalent to 32-bit. Okay, let's try to look at by using the what you call that? Sorry, I'm going to open up the calculator. That's the calculator. Okay, you can go to your mode base 3. Okay, for example, decimal again, right? Let's put A, number 10, hexa A. Okay, then you can convert to decimal, which is 10. You convert to hexa, is A. You convert to binary, there will be 4 of it. Let's try for the case of lower than 10. Maybe it's not going to be full. I'm not so sure. Let's double check on that. 8 on decimal. 8 on decimal. And then you go for binary numbers. Still, this is going to be 4 digits. Try again, maybe 7. Okay. So binary, this is not going to show. But it should be 0 here, because if you want to convert 7 hex to binary, okay, 7 hex to binary, for example, for 7 in decimal, it's the same one, 7 in hexa, but the number will be going to be 0, 1, 1, 1 in binary. So it must have these 4 digits for the binary. So you can see that for the data register, address register, the program counter, all are using hexa representation number, but the status register is not using it. It's using binary numbers. This is only the exception of the representations of the register. So this is binary numbers. Okay, so far so good. You have to look back this one and then understand the concept. The pins are different. The registers are the one that being seen in the software. Okay, let's look at the software again. Now you have this one, right? You have this code. Then by the process that I did just now is I stop at this particular line. I do not execute it. So in this command, this is very simple command. What I want to do is I want to move a byte size. Byte is 8-bit. So 8-bit just now, right? So it's 8-bit. So for byte is equivalent to 8-bit, and it will be represented by 2 digits of hexa numbers. For example, just now is AA, because A got 4, 1, 2, 3, 4. Another A is 1, 2, 3, 4. This is 1, 0, 1, 0. 1, 0, 1, 0, 1, 0, 1, 0. So the total will be 1, 0, 1, 0, 1, 0, 1, 0. This is the binary numbers. Okay. So go back to your Easy68K. The command is going to move dot byte hash $. This is hash means that is going to be an integer, and not integer. What do you call that? This is a number. Okay, this is not a variable. This is a constant number. So hash $, a constant number AA will be moved to D0. So I'm going to execute. If you want to execute one by one, you can click this button, trace info, which is the F7 button. You can trace info this one. Before that, you can look at the register at D0 here. There's, by default, there's nothing. So once I push this button, the AA will be moved to D0. So now this D0 will contain AA. AA is in hexa numbers. So if you put like this value, means that if you want to look at this value, it will be like this. This will be going to be 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. This one should be 1, 0, 1, 0, 1, 0, 1. So this is only sorry. This is going to be all 0. This is going to be all 0, right? It's all 0 here. Up to this one. This is going to be 1, 0, 1, 0, 1, 0, 1, 0. So this is the 8-bit size. Okay, so this is the 8-bit size on that. Okay, what else that you want to see over here? So this is the memory and the address. So the memory is what is now? The memory is this one. If you go back to the lecture last time, the memory is outside from the CPU. So remember that the memory, how much memory can be accessed is based on the pins of address pin. So for example, here in this example, you have A0 to A23, so you have 24 pins. Means that the total memory which can be accessed is 2 to the power 24, which is around 16 megabyte. And the address must be started from 0 to 2 to the power 24 minus 1. So this is the address, unique address. Then you can draw the memory map. This is the memory that we are going to represent. So the first one is going to be 0, and you can see that this is going to be 6 digits only because of the total pins of address is only 24. So each of the digits here represent 4 bits times, so this is 24, so 6 times 4 is equivalent to 24. So it relates to the pins for the address pin. Okay, so the last location will be this one, FF. This is the last location. So where you want to see at the ID 68K. So here you can just go view, then go to the memory. So this is your memory, and by using 68K, the only memory can be accessed is around 60 megabyte, which is around 0000 to FFFFF. So how to read this one? You can go to the first address, which is 00. So by default, all the values inside your memory are all FF. So for example, here 00 is FF. F means 1111. Another F is 1111. So by default, the contents of location 00, this you have to read like this. 00, this is the starting points of your starting locations of your memory. So this is going to be 001, 00, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F, and then you will go here 10. After F is 10. Then the by default is FF, means that the value for the memory is going to be all 1, 1, 2, 3, 4, 5, 6, 7. This is all the default values when you run your IDE 68K. So what happened to the command just now? This command is putting to D0. So means that there's nothing you can put to the memory location. This is the one that we have to. So what happened is your memory will contain the execution code, which is this code in the hex file. This is, they call it the hex file, which is consists of the machine code. So why do you put the origin 1000? Because this is where do you want to put your program. When you compile this line, it will generate a machine code. That machine code is represented this one. So this command is in machine code for this command. So you can go to origin 1000. This is where you want to put your code. You can go to this memory location 1000. How to go to that one? You can just go directly to 1000. Then you can see that this code had been inserted at this location 1000. So normally in our software simulation, we are going to use 1000 area to save our program. So you can see that 10.3C00AA in hex file. So memory, the size, each memory is only 8-bit. So it can only have 2 digits of hexa. For example, this one just now, you have FF here. Let's say for example, you want to put AA, means that it will going to be like 1010, 10, and 10. So only 2 digits will be covered to one location only in the memory. Okay, so this is the one. Okay, now you have the command to put in the data register. Okay, I just want to try another one. I want to move something to the memory. Let's try another one example. So I'm going to move, after I move the contents to D0, I'm going to move this content, move.bytes to from D0 to the location. Maybe I just want to go to $2020. So is it a problem? Let's try. There's no problem. Just execute it again. Okay. So you have the command here at 1000. See, this is a command. The full command is this one. This is after you compile it, you will get the machine code. This is the machine code for this one. You don't understand this, we understand this. Okay. So the first command is going to move by AA to D0. So we're going to move this one. Okay, this is move already there. Now the second command is to move the content of the data register AA to the location 2020. Now look at the location 2020. Still by default is FF. So let's move the value D0 to 2020 in the byte size. So I'm expecting AA to be inserted over here. Let's look at. So it's correct. Means that I have moved a value in byte size from D0 to the locations of $2020. This is representations in hexa numbers 2020. It will go to the locations 2020. So remember that in the address representation, right? You must use $, which is a hexa numbers, because we cannot afford to use binary because it's very long. So we try to use hexa. It's much faster and shorter. And you can see that by using the memory map, we only have 8 digits for hexa, but inside the IDE 68K, the digit is 8. It will use all 32-bit, but the one that we're going to use is only 24. If you accidentally close the window for the memory, right? When you want to run again, you can see the memory. So you have to go back to your view and then go to the memory again. So you're going to look at the memory here and the contents of it. So that is the basic method how to use your IDE Easy68K. This is where you're going to write most of your codes and you want to understand how your code is going to be executed. Okay, that's all for today. Thank you very much.